Hello and welcome to the GitaCloud Explainer video series, for time series supply planning. This series is aimed at supply planners, and any other IBP practitioners. This is part 1 of the adjusted key figures topic, to learn how planners can override plans generated by SAP IBP. Planners often need to override IBP-generated demand or supply plans. For example, supply planners in the consumer products industry may need to inflate demand on DC, to support a last-minute customer promotion. Production planners in the life sciences industry may need to block all production of certain drug formulations from a given plant, while quality issues are resolved. Component buyers in the high-tech industry may only get partial supply from component suppliers, given chronic chip shortages. Let's see how IBP supports planners model constraints in such situations. We will focus on customer demand override scenario to manage shipments from a distribution center to a customer. In this example, customer in EMEA region gets the product IBP 100 from distribution center 3710. Note the consensus demand for IBP 100 in EMEA region. Customer source master data type allows us to specify how to meet this consensus demand from the distribution center. Customer transportation lead time, from DC to customer, is 2 weeks. As a result, customer supply key figure shows how 100 units shipped from DC in week 41 reach the customer in week 43, as seen in customer receipts key figure. Note all the adjusted key figures are blank in this initial state. Sales team just communicated that EMEA region customer will be running a promotion, and needs higher quantities of 75 and 85, in week 37 and 38, instead of the consensus demand, 40 and 50. Demand planning process has already concluded for this month and consensus demand key figure is now locked for edit. Supply planner decides to model this change with the help of outbound customer demand adjusted key figure. Let's evaluate how the planning results have changed post this planner override, based on TS supply heuristic run. Notice how the adjusted dependent customer demand key figure has inherited the supply planner override. These inherited values are shifted left on the time axis by 2 weeks, to account for the customer transportation lead time. This is an example of how downstream key figure coupling works in IBP. TS supply heuristic also updates the outbound customer demand key figure, and customer receipts key figure. As you can see, consensus demand key figure values have been ignored in favor of the planner override in week 37 and 38. Note the upstream and downstream key figures here. Both can be used to override consensus demand. This presents a data integrity challenge, if the supply planner edits both, and accidentally provides disconnected values, as shown in this example. The downstream values of 72 and 82 are different from the upstream values of 75 and 85, in weeks 37 and 38. Parameter merger policy for key figures can be set up to control the synchronization across upstream and downstream key figures. In case of merger policy being upstream key figure leading, IBP will override downstream key figure values with upstream key figures. As you can see, the values of 75 and 85 in upstream key figure have been copied into the downstream key figure as well to make the override consistent. In case of merger policy being downstream key figure leading, IBP will override upstream key figure values with downstream key figures. For example, the downstream key figure values of 72 and 82 have been copied into the upstream key figure in this case. IBP administrators can leverage reset adjusted key figures parameter to initialize all the values in adjusted key figures. Be careful, as this will lead to an irreversible loss of data in adjusted key figures. Best to copy these adjusted key figures into backup key figures using copy operators before you initialize planner overrides. As you can see, TS heuristic has initialized all the adjusted key figures to return the planning situation to its initial state. In conclusion, adjusted key figures provide a user-friendly option for the supply planner to model demand exceptions. See part 2 of this adjusted key figures topic to understand how production planners can model demand on production plants differently from downstream demand from DCs. You can find this and all other IBP Explainer series videos at GitaCloud website or GitaCloud YouTube channel. SAP IBP has a wide range of demand or supply planning features that your planners may be interested in. GitaCloud can help you understand how IBP can model your specific planning problems and how that adds value to your planners. You can reach us with a quick email to connect@GitaCloud.com. Hope you enjoyed this video. Please like and share if you did. Have a great week.